All right, ladies and gentlemen, so today we're going to take a look at the angle sum of a triangle, and we're going to also use some of our stuff with parallel lines to help us out with that. So first thing, name the triangle in the figure. So your triangle is right here, all right, which is going to be triangle BCF. We also have these two straight lines, line 1 and line 2, and then we have a bunch, we have two different transversals. So then it says use color to show the relationships between the interior angles of the triangle and angles formed by parallel lines. All right, so this, I'm going to talk right here. Let me actually erase this stuff first. All right, so I'm going to take a look first at B. So this angle right here, which is inside of the triangle, is vertical to this angle right here, because they're diagonal from each other. All right, I could also say that if I'm looking at my parallel lines idea here, that this, the one that I did in blue, right, if I take and translate it down, is also going to be the same as this one. So I'm not sure if that's going to help us or not. I have angle C up here, right, and then that's vertical to this one. And again, if I take and translate this down, I keep moving it down, then it's going to be the same as this one right here. Not sure what I'm going to need yet, so we'll just keep doing that. I have angle, this one is congruent to this one. And if I take and translate this up, I actually can't really do that part, but that's okay. All right, so name a straight angle that will be useful in providing that the sum of the interior angles of a triangle is 180 degrees. Well, if you look, right here, I have all three colors on this line. I have all three of my colors. I have green, I have red, I have blue. So that straight line is, I think that's a G, GE, right, is your straight line. So this, we know from last year, this is 180 degrees. It has all three colors. The triangle has all three colors, which is how we can say then that the angles of the triangle are 180 degrees. So that was just kind of trying to show you. So now we're going to do some simple math, hopefully. So if I know two of the angles, and they have to add up to 180, I can add these two together, which is going to give me 147, and then subtract it from 180 degrees. So that's going to give me 33. So this angle, angle C, would have to be 33 degrees. Remembering that our box, right, you know this from last year as well, is 90 degrees. So I'm going to add 51 and 90, 141, subtract from 180 degrees, which should give me, I hope I did that right, 39. All right, let's see what else we got. Pretty easy stuff, I like it. If FGH is an equilateral triangle, what is the measure of each angle? So equilateral means that we have three equal angles. So that means I'm going to take my 180 and I'm going to divide it equally among three angles, so they're each 60 degrees. All right, now we have a little bit more going on here. So it gives me all this stuff. It's telling me basically what's in the picture. And I want to find the measure of angle CED. So CED is this one right here. All right, well, I know, right, I have this one, this 42, so that's helpful, but I need this one first. Well, these are parallel lines that are cut by the transversal. These are alternate interior, which means this one's 28 as well. So 28 and 42, now that I have two of the angles, it's going to give me 70. 180 minus 70 is 110. And, oh my gosh, that's it. Look at how easy that is. All right, so you know the drill. Any questions, you're going to bring them to class. Otherwise, have a good night.